We're going to go through graphs for quantitative data. The three graphs we'll look at are the dot plot, the stem and leaf plot, and the histogram. A group of 7 randomly selected Hillsborough County residents were asked how many times they went to the beach during the months of June and July. The responses are below. To create a dot plot, first draw out a number line. Next, put a dot above each number on the number line. For the 1, I'll put a dot, 3, dot for the 5, and a dot for the 7. In the next example, we're now in Pasco, Hernando County, and we'll create a dot plot for these 7 residents. Draw out your number line. We have 3 1s, a 4, and 3 7s. And in the third example, we move into Manatee County. There's a 1, there's 1, 2, 3, 4 2s, a 4, and a 7. If you notice, these 3 dot plots look very different. The first one, if you were to fit a general shape, would have a bell shape to it. If you were to fit a general shape to the Pasco-Hernando County data, it would come back as bimodal, meaning it has 2 peaks. And if you were to fit a curve to the Manatee County data, it would come back with a skew. And in this case, since the tail drops off on the right-hand end, it's what we will call skewed right. Let's discuss common distribution shapes. In a symmetric shape, the left and right sides of the distribution will be mirror images of one another. A uniform distribution is symmetric. All values are the same height, and the left and right side from any point would be identical. A bimodal shape has 2 peaks. Cases where you may see bimodal data, let's say we're discussing heights. This could represent the average height of males, and this could represent the average height of females. These would be very short females, tall females and short males, and very tall males. Unimodal distributions have only 1 peak. The most common would be the mound or bell-shaped. They're skewed left, the tail drops off to the left, or in skewed right, the tail would drop off to the right-hand end. The next graph that we'll look at is a stem and leaf plot. To create a stem and leaf plot, first order your observations from smallest to largest, and I usually order my observations vertically. Next, you're going to break your observations into what's called a stem and a leaf. Then finally, you're going to write the stem once with leaves stretching off afterwards. General pictures can have this shape, and in this case, this would be skewed left, this shape, this would be bell, or this shape, this would be bimodal, or the data could be skewed to the right. Let's go into an example and see how to create these stem and leaf plots. The data below represent the number of domestic violence offenses that occurred in Hillsborough County during the year of 2011, rounded to the nearest thousandth. The numbers correspond to total offenses within the county in which the offender was the spouse, parent, child, sibling, other family, cohabitant, or other of the victim respectively. We want to create a stem and leaf plot and interpret the data. The first thing I'm going to do is order my observations from smallest to largest, and I'm going to leave off the series of 3 zeros here. The way I'll remember that there are 3 zeros is to just say that the leaf unit is 1,000. So that's a placeholder for the 3 zeros, and I'm really looking at numbers like 7, 8, 9, 12, 19, 23, 32, and 112. The next thing I'll do is break the data into the stem and the leaf. If you think of 7, 8, and 9 as having zeros in front of them, you could divide the data down the middle. The left-hand side is the stem and the right is the leaf. We'll rewrite these stems exactly one time. If you notice when I rewrote the stems, I had to skip some numbers between 5 and 11, and that's just because of spacing on this program, but you should be writing out. Now that the stems have been written once, we'll come and fill in the leaves. Next to a stem of 0, we have leaves 7, 8, and 9. Next to a stem of 1, we have leaves 2 and 9. Next to a stem of 2, we have a leaf of 3, and then 32, and then 112. If I were to ask you to describe the overall shape of the data, you want to picture a smooth curve running over the top of your numbers. And if you think of rotating your number line in this direction so that it runs like this, the curve would run in this shape. Remember, you want a smaller number down here and 11 bigger number up here. So we're thinking that this is a tail dropping off to the right hand side. This would be a shape called skewed right. Some other things I could ask you to do are identify the value of your largest observation. In that case, you would go to your largest stem and your largest leaf and combine these together to get 112. Then multiply this by your leaf unit of 1,000. Together, this means the value of your largest observation is 112,000. Now let's say, for example, I changed this leaf unit to something like 0.1. And then I were to ask you what's the value of your largest observation. Well, again, you would come in and get your largest stem of 11, your largest leaf of 2, but this time when you multiply by a leaf unit of 0.1, it will give back a different answer. In this case, your answer is 11.2. So you can control the values in your data set using this leaf unit. We can also compare two data sets by creating a back-to-back stem and leaf plot. The data below respectively represents arson of the following structures: storage, industrial manufacturing, commercial, community public, all other structures, and motor vehicles within Hillsborough County for the year 2011. The first data set is for inhabited structures, and the second data set is abandoned structures. To create our back-to-back stem and leaf plot, I'll first order the inhabited observations from smallest to largest. Next, I'll order the abandoned observations from smallest to largest. Let's divide these into our stem and leaves. And here 7 and 8, remember they start with 0. Same on 2, 6, and 7, they're going to start with 0. So if I'm looking for stem values, I know that they need to range from 0 to 9 or 0 up to 2. So overall, a scale 0 to 9 should do very well for our stems. For the inhabited data set, we'll now fill in the leaf values. For inhabited, we have leaf values of 7 and 8 next to the 0, of 1 next to the 1, of 4 next to the 4, and then 93 and 94. For the abandoned data set, we have the numbers 2, 6, and 7 next to a stem of 0. Then we have the 11 and 13, and then the 25. To compare these two populations, let's start by describing their shapes. For the inhabited data set, the overall shape appears to be bimodal. For the abandoned data set, the overall shape appears to be skewed right. One of the ways I knew it was skewed in a right-hand direction was I pictured taking the stems and putting them on a scale running from 0 to 11. And then I decided which way to rotate the graph. For 0 to end up on this end, I need to rotate in this direction. So my shape would go like this, producing a skewed right. The next thing we could discuss is the center. It appears that the bimodal distribution has a balancing point or a center around 44, whereas the skewed distribution appears to have a balancing point or a center somewhere between 7 and 11. We could also talk about the spread of the two distributions. For the inhabited data set, it appears there's a lot more variability in the amount of arsenary, whereas for the abandoned data set, it appears most arsenary values are close together. There's less spread. Some general pictures of histograms would look as follows. We could have your bell shape, or symmetric. There can be bimodal, skewed left, and skewed right. Oftentimes people will show overlaying a curve on these data sets. The point of the curve is just to emphasize the overall shape of your graph. For example, the frequency table below gives the time and their frequency and relative frequency in seconds for the 2012 ranch rodeo cow milking teams. We want to create a frequency histogram and discuss how to create a relative frequency histogram. The first thing I'll start by doing is creating a set of axes. If you look in the class, we'll use these to create the horizontal scale. Notice that the first value starts at 32 seconds. So we'll show a break in the graph and then start up at 32.5. We should also label the axis as time. Along the vertical scale, we'll write in our frequency. If you look at your frequency values, they range from 1 to 6. Next, you want to draw in your bar height. Next to 32.5, we have a bar height of 1. Between 38 and 43.5, a bar height of 2. You could even write in these heights here just to remind yourself. Then a bar height of 4. Then a bar height of 1. Bar height 4. And bar height 6. Now we have one more category to graph, which I purposely left off, the no time category with a frequency of 3. No time means you scored a 0, but we're going to have some kind of upper bound here for this frequency. And to figure out the upper bound, what you want to do is figure out how much you are adding to each category. So if you come in here, 37.99 minus 32.5, that will give back 5.49. Same thing if you do it here, 38 and 43.499. That will give back 5.49. Every single time we're adding that number on. So if you're looking in this height, it's saying that there were 3 observations with a time of 5.49 or less. And the or less is the true answer. It's really that it was a time of 0. To interpret this, we should come in and draw an overall shape. Before we interpret this, it's important to keep the scaling in mind. So let's redraw this graph. And this is, if I'd had enough room, this is how it would have looked. Your score at 0, and then jump way out to 32, and you start getting in these heights. So this is all by itself, and then you have a general shape over here. So if we're really wanting to describe the graph, we should probably come in and focus on this portion of the graph. If you're discussing the shape of this part of the graph, it does appear that it's skewed left, which would be supported by coming way out here, skipping this big gap, and there's some observations right in here that just further extends the skew. These are the works cited for this lecture.